Today this video I'm Mr. Pakistani and you are watching Mr. Pakistan and today this video I will teach you what is inside this shaft at power supply. So in the table, this shaft at computer 80H power supply model, let me see, model GPS 450A, 450A 10-1001 1 amp 1A. It is a 450 watt power computer 80H power supply. Input 220 volt, 100 volt to 220 volt output, several voltages, light, 5 volt, 12 volt, 3.3 volt and 5 volt standby. There are twice of wires. There are yellow, red, black and orange wires for power wires, and there is a green wire and some wires. There are too much wires according to the computer, so there is a twice of wires. Some is plugged in motherboard. It is a desktop computer power supply, and some is plugged in hard drive, CD-ROM or etc. This is a hard disk table and this is a CD-ROM table, and there is some other tables like floppy disks, and there are 4 motherboard tables. These 3 tables is those of motherboard. There is twice of table, but what is simple. First, third table. Yellow, all the yellow is 12 volt, 15 ampere. Below is 12 volt negative. Let me see how much ampere is. Below negative 0.5 ampere, and orange for 3.3 volt 30 ampere, brown 3.3 volt sends to feed power supply when the computer is working with 3.3 volt is properly doing the computer or not. Purple for standby power, so it is turned on the computer. Standby mode, it can turn on the computer with processor turn on by this purple wire, and green is power on and gray is PG wire. So now so PG is a sense wire, which then this gray wire is known as a PG wire. So this wire then sends that 12 volt and tell this power supply all the voltage is stable or not. And this is a standby wire. It turns on the computer RAM or processor when the computer is standby mode. And this is a 3.3 volt sense wire. It can stay at 3.3 volt by this orange wire and give it back to a power supply to tell power supply this 3.3 volt is properly. I mean, there is no any drop past this wire. And green is power on. So normally power supply is standby mode. All we need to do is then push the button. When you push a computer button, you can join these green and black wires to turn on this power supply, enable power supply, and power supply give all the outputs. Only when power supply is off position, there is only 1 volt, this 5 volt standby voltage. Standby voltage is only present. All the voltage is turned off. It is only be available when power supply is started in mode. And this is a computer power supply. That's why there is a input 10 to 20 volt, output several voltages like plus 5 volt, plus 3 volt, plus 12 volt, plus minus 12 volt and 5 volt standby. These all voltages come by single unit. There is a total 440 watt power supply. Now what is made by a shaft at. Now see what is inside. Now it's open. Before that we check the setup. We test the problem, but the problem is accidentally do it. First, what is happening? I plug my power supply in my computers. So I accidentally close the lid of the computer with entirely. So let me see the one of the wire. Which wire is? Yes, this wire is. This wire accidentally comes off in the cabinet of the CPU, because CPU cabinet is made of metal. It is a grounding to a chassis of a power supply chassis is ground. So there is easily this yellow wire snap off with terminate between chassis and short to a ground. That stand cause a short circuit and this power supply is burnt out. That's why there is an all the voltage is missing. Instead, we that standby still getting standby voltage in these plugs, and all the other voltage is missed out. So we need open and take what is inside plus problem. What is the problem inside of this power supply? And this power supply is always affiliates with mains, but it's still due to high current. It can tell you directly. Never try this. Now we can need a jumper wire in order to start the power supply. Because this time standby wire voltage is always coming. You will know it's connected, power on or off, but still I attach this jumper to the green wire to the any one black wire, because all the black is same job, but the same job, all the yellow is same job, what same. Now I bridge the green and black wire. Now what I tend to do, we get a power cord, plug into the power supply first. Properly see what it's doing. Yes. Now turn a switch, because I don't touch metal casing while it's turn on. And now plug the switch, and it's produced some amount of noise. Never try this. I send my analog multimeter to DC 10 volt. So voltage term must be at 10 volt, 5 to 10 volt range, or 12 volt, either 12 volt range. So what I tend to do, first unwrap the wire. Now I one socket over this side, because you may know negative is always common. So I connect the one wire directly to a negative, and this is a test lead, which I connect a pin. Don't touch the exposed wires to this purple. Now I connect the wire. If you can see, there is only showing 5 volt standby, which is, you can see here the settled purple wire is connected to this red probe, and black probe is ground into a ground wire, which I cannot show right now without it is to a ground side of the table. I could not, and you can see there are standby voltage is coming. When I check in 3.3 volt, which is auxiliary voltage, no available. 12 volt, which is also auxiliary voltage, I mean 88 voltage, so multimeter is not available, and 5 volt still be not available. So only this voltage be available, which is the standby voltage. And now you can easily see the other probe is a ground together with this black probe. Now see what is inside this power supply. Keep in mind, when you open power supply, make sure your power supply, never open power supply. It will own cell, because it contains high voltage capacitor bent inside, which can get electric charge after it's turned off without it store the charge. And other thing, these power supply are, if you turn on the power supply, and if you are expert, then you can leave the power supply turn off about 1 hour, then open it. Never open, just plug and see and open it, because it contains high voltage inside. Just for example, I open this and see what is inside. Once dim to driver. So there are 2 screws and 2 screws bottom side, 4 screws for lid, and 4 screws for fan. Now open one by one screw. Although one screw is missing right now, but still remains screw right of left. So it's come out like that. Now I put this screw out so it's not jump to my bottom of the table. Now bend it. Now open these remaining 2 screws, and after we open the fan screws, then we reveal inside So this power supply is not repairable due to these power supplies are thin, which thin is only be when service by service center or when it's in the warranty or without warranty. Service center will repair. Any local person cannot repair these type of power supply because these power supply contain very high voltage. So never try to repair these type of power supply if you have these dead power supplies, because they contain high voltage inside. After it's plugged out, it's stored about 1 to 3 hours high voltage charge, which can directly kill you when it's opening. So now open it. Carefully. Their screws are a little bit wobbling. This time there's a quite of screws. This is very easy to come off. Easy, like that, and hold it. Now I grab this and just pull up like that, and now bottom side also pull like that. Never touch the bottom side because this side is I will need capacitor bent, we can get electric short, and carefully slide out the wire inside. We need to also move the wire out to the side of the cabinet. This time this power supply takes a little bit effort to open it. Now this is a fan, and there's inside a power supply. Inside these is a capacitor band, which this capacitor is a single capacitor. Most of the time we have two capacitors. This capacitor rated is 330 volt. So it both if are two capacitors, there are two in series. There is a single capacitor. So if you single charge this capacitor leads you get electric short, and there are a couple of cards. Now further open and see what is inside more. So open this fan screws in order to reveal the fan. There are 4 screws. This time I am carefully remove the screws all because they are not fall down my table. So maybe we need a stool. Save them. This screw I am saved the screws. Future maybe I need the screws. So I there are screws. Carefully remove it, not fall down to my table. So later we can reuse the screws for some other purposes, or if maybe repair it, and then we try to repair and reuse them also. But I don't think this is easy to repair. First, totally full removed. It's like that. There's 1 screw left and 4 screws more left to the bottom of the board. Now to remove completely and then see what is the total all info. I also keep this fan, so maybe future I also use this fan to make some source of air cooler, because this fan is looking big to a normal fan. First check fan rated. Make sure this is black cover, you cannot see easily, or maybe camera can see easily. This is a D12SH-12F 12 volt fan, 12 volt and 30 ampere, 0.30 ampere, which means 300 milliampere DC fan. Now open the bottom side, and bottom side there are 4 screws. 1, 2, 3, 4. And this screw is a down screw. So there's a grounding table to ground them, which can, although I sit outside, is a really nice ground them to this, all the ground coming together with this wire, and this is a earth wire to discharge when it's actually in condition, it's come live. Now open screws, and there's a tiny little component. This is a primary side. This is a primary side. This is a primary side, and this is a secondary side. Now, this screw process takes a little bit time, extra time, instead of this old thing. Now open this one. I not remove this screw because this screw is only to connect the ground wire, which wire is connect input jack, input power connector to a chassis, which will not connect to the board. Now once this screw is open, it easily come off like that, and bottom screw is also come out very easily instead of opening, I think. And there's a wires switch, and there's a wire. And one more thing I realized when I opened it, so you can see there somewhere there, this that is blast out. So if you zoom it a little bit, we can see this that is blast out, which will be connected like yellow. This is a yellow wire, which will maybe connect this jumper to this big track. So just I tell them this yellow wire is shorting to the chassis of the CPU, cabinet of the CPU. So CPU cabinet is ground. So this is a 12 volt positive wire, which will be connected at this point somewhere, and this point will be jumped by this jumper to this big track, which is blast out there. Meaning if you join this track to the other solder RAM, it may be run out. It's what again. In order to do that, we can bridge the solder wire to solder these points, and then maybe it could work. And right now, this is I try this thing in the next part of the video, because this video is in two parts. And there's a front side, back side of board, look like this. Back side is couple of zeros and IC, and there's a IC and some couple of transistors and couple of capacitors, and front side will look like that. This is a power factor correction card, and this is a feedback card. So this card measure the input voltages of these wires and give to the feedback via upper to this IC. So this upper is isolates between low voltage and high voltage side, and this is a power traction IC. So when it's then a soft start circuit, when this circuit is middle of the sine wave, it can slowly take the power. Instead jump or fly out, it can slowly take the power and slowly in the middle of the sine wave. So this is a power traction circuit.